Today's video I have brought you a very nice problem. Here is the following setup. Find all positive integers x and n such that we have this following statement: x to the n plus 1 plus 3 to the n plus 1 plus number 2, okay, is a multiple of x to the n plus 3 to the n plus number 2, okay. In the other word, x to the n plus 3 to the n plus 2 divides this one, okay. So the way we solve this one, we just first of all are going to check these cases when we have n equals 1 and n equals 2 to see what's the expression and what's the relationship between this one and this one. What's the multiple of this number, okay? So let's check this case when we have n equals 1 by replacing both terms with number 1. X squared 3 squared plus 2, which is 11, is a multiple of, we'll have x as a first term plus 3 to the 1, which is 3, plus number 2, which is 5, okay. So we're saying the number is a multiple of another number, so which means we will have a shared term as a factor, okay. So I can rewrite this one as x squared minus 25, which equals x minus 5 factor x plus 5 is a multiple of x plus 5. On the other side, if I'm going to take the difference of this term and this term, is also the difference is a multiple of x plus 5. Or the sum of this term and this term is a multiple of x plus 5. For example, if you have, I'm going to take 27 is a multiple of 3, okay? And also, we know 18 is a multiple of 3, okay? So if I'm going to take this difference, I will have 27 minus 18, which is 9, is a multiple of 3. So the difference of this number is a multiple of 3. Also, if I'm going to take the sum of these numbers, so I will have 27 plus 18, which is 45. 45 is a multiple of 3. This is what happened here. If I'm going to subtract this one from this one, I get a multiple of x plus 5, okay? So, which means I will have x squared minus this one, x squared will be eliminated. I will get 11 minus 25, which is 36. That means 36 is a multiple of x plus 5. So, which means x plus 5 is a factor of 36, okay? So, which means x plus 5 equals x plus 5 equals number 1 or 2 or 3 or 6 or 9 or 12 or 18 or 36, okay. This is all the values x plus 5 can take, because if I'm going to replace this one, I'm going to replace x plus 5 with one of these numbers, so I will get a factor of 36, okay, which means 36 will be divisible by these numbers, okay. So we have x plus 5 equals, first possibility equals 1. Impossible to have x plus 5 equals 1, because since we have a positive integer, which means x plus 5, it will start from number 6, okay. Because if x is taking number 3, I will have 3 plus 5, which is 9. 9 is bigger than these divisors, okay. So this is the first one. Second possibility, x plus 5 is going to take 9, x plus 5 is going to take 12, x plus 5 is going to take 18, and x plus 5, and finally x plus 5 is going to take 26. So I'm going to extract all the values of x. This one is giving us x equals 6 minus 5, which is 1. And the second one is giving us x equals 9 minus 5, which is 4. The third one is giving us x equals 12 minus 5, which is 7. The fourth one, x equals 18 minus 5, which is 13. The last one, I will have 36 minus 5, which is 31. So all these values of x are the solutions for this equation, okay. All of these values with n equals 1, okay. This is just the first Abbe's case, which means the pair of the solutions of this one which I have n equals 1 with x equals 1. So this is just case n equals 1. Let's move on when we have n equals 2. Okay? N equals 2. I'm almost going to do the same job as I did previously in the last case. So I will have n equals 2. I'm going to replace n with number 2. I will get x cubed plus 3 cubed, which is 27, 27 plus 2, which is 29, is a multiple of this term. Square, which is 9, 9 plus 2, which is 11. Okay? So I'm going to use a little trick here. I'm going to multiply this term by x. It becomes a multiple of x squared plus 11. Okay? We have x is multiplied by x squared plus 11 is a multiple of x squared plus 11, because always a multiple is bigger or equal to divisor. Okay? So I will have x is multiplied by x squared plus 11 is a multiple of x squared plus 11. Okay, like this. So if I'm going to take this difference as I did in the previous case, by taking this term minus this term, or this term minus this term. So the convenient one, if I'm going to take this one minus this one, because we have x, 11x here. So I will have, if I'm doing that, I will have x cubed minus this x cubed, so it will be eliminated. I will get 0 here. So I will get 11x, I will be left with 11x minus 29 is a multiple of x squared plus 11. So as I said before, the difference of these two numbers is a multiple of x squared plus 11. Okay? So now, expression is telling us this one is written as numerator, this one is written as denominator. Okay? Which means x squared plus 11 divides this term. Means always numerator is bigger than denominator. Okay? So which means 11x minus 29 is bigger or equal to x squared plus 11. Okay? So what I'm going to do now, I'm going to take all this stuff to the right side of this equation. This one is the same as x squared minus 11x plus 40 is inferior or equal to 0. Okay? Now the contradiction starts showing up. So I'm going to prove this one is strictly superior than 0. So without using discrete delta, I'm going to use just a little trick here. So by putting this one as a quinary square, so this one is the same as x minus 11 over 2, quinary square, 21, 11 squared, 121 over 4. I'm going to subtract this number because we don't have it here, which means minus 121 over 4 plus the original term, which is 40. So if I'm going to calculate this one, we'll get plus 39 in numerator over number 4, okay? Which is strictly superior than 0, this one. But this one is inferior to 0, which is clearly is a contradiction, okay? Which means we don't have a solution when we have n equals 2. So which means all other terms which coming up maybe not the solution as well. So we are going to prove this one as a general case, okay? So if n is superior to 3, like this, okay? So in this case, we will have n is superior to 3, okay? As a given information, we have x to the n plus 1 plus 3 to the n plus 1 plus number 2 is a multiple of x to the n plus 3 to the n plus number 2, okay? So I'm going to do the same work as I did previously, number 2. So we'll have x is multiplied by x to the n plus 3 to the n plus 2 is a multiple of x to the n plus 3 to the n plus number 2. Now I'm going to take the difference of this one and this one. I will get x to the n plus 1 eliminated. So which means I will be left only with 3 to the n plus 1 minus x is multiplied by 3 to the n plus number 2 minus 2x what about this one? Is a multiple of this one, okay? Is a multiple of x to the n plus 3 to the n plus number 2. Which means the difference of these two numbers is always a multiple of the same number, okay? The n plus 3 to the n plus number 2 is inferior or equal to this term, which is 3 to the n plus 1 minus x is multiplied by 3 to the n plus number 2 minus 2x, okay? So which means I will have x to the n plus 3 to the n plus number 2 is inferior or equal to, so I'm going to take 3 to the n as a common factor. I will have 3 to the n is multiplied by 3. This one will be multiplied by minus x, okay? This one, I'm going to take the number 2 as a common multiplier. I will have 2 is multiplied by 1 minus x. The next thing up, I'm going to take minus 1 as a common factor for both terms, okay? So which means I will have x to the n plus 3 to the n plus number 2 is inferior equal to minus of 3 to the n. I'm going to switch this order. I will have x minus 3 plus 2 x minus 1 like this, okay? So what do we know about this number? If you have x is superior or equal to 3, always this term is bigger or equal to 0. This one is also strictly superior than 0. Okay, we know that, right? So with this minus sign, everything is towards the negative, okay? Which means this term, it will be negative, strictly inferior than 0, okay? What does this mean? Which means this term is strictly inferior than 0, which is impossible because we know this term is strictly superior than 0. Because this term is a positive integer plus 3 to the n plus number 2, okay? Which is clearly is a big contradiction. But this one is happening when we have x is superior or equal to 3. So we need to check two cases. When we have x equals 2, must be a contradiction as well in order to have the proof completed, okay? So that's what we want to do now. I'm going to check the two cases. First of all, I'm going to check when we have x equals 1. So I'm simply going to replace x with number 1 into the first setup. I will have x will be replaced with number 1. I will get number 1 as a first term plus this number 2, which is 3. So which means I will have 3 to the n plus 1 plus number 3, okay? What about it? Is a multiple of this term. Is a multiple of this one. This one will be replaced with number 1 here. I will get 1 plus 2, which is 3, which means I'll have 3 to the n plus number 3. And also I'm going to take this number and multiply it by number 3, which means I will have 3 is multiplied by 3 to the n plus number 3. I'm going to leave it like this to be visualized, okay? So this one is a multiple but of this one, 3 to the n plus 3, okay? It's clearly is a multiple of this one because this one is a bigger than this one, or this number is multiplied by another number. So a number is multiplied by the same number, of course is a multiple, okay? So what I'm going to do now, I'm going to take the difference as I did before. I'm going to take this difference, this one minus this one. So which means I will have 3 to the n plus 1 will be eliminated because I will have here 3 to the n plus 1. So plus 3, we'll have 3 minus 9. So this difference is a multiple of this one. In the other word, this difference is superior equal to this one by the definition, okay? So which one is superior equal to 3 to the n plus 3. I'm going to cancel out number 3 from both sides. It means minus 9 is superior equal to 3 to the n, which is clearly is a contradiction. Totally is a contradiction. Okay, never ever minus 9 is superior equal to 3 to the n. Okay, so which means x equals 1 is also ruled out of this possibility, which is not as a solution. Okay, so I'm going to check this one quickly. So we're going to have x equals 2 with n superior equal to 3. Okay, I will get 2 to the n plus 1 plus 3 to the n plus 1 plus number 2 is a multiple of this term 2 to the n plus 3 to the n plus number 2. Okay, after multiplying number 2 by this one, it becomes a multiple of the same number. Okay, so which means 2 is multiplied by 2 to the n plus 3 to the n plus 2 is a multiple 2 to the n plus 3 to the n plus number 2. Okay, so to take this difference, this one and this one, so which means 2 to the n plus 1 will be cancelled out with 2 to the n plus 1, because 2 is multiplied by 2 to the n, it becomes 2 to the n plus 1. So which means this difference will become 0 here, and also I'll have 3 to the n plus 1. I will be left with 3 to the n plus 1 minus 2 is multiplied by 3 to the n plus number 2 minus 4. Okay, is a multiple 2 to the n plus 3 to the n plus number 2. Okay, it means this term must be inferior or equal to this term, because this one is a multiple of this one, which means I will have 2 to the n plus 3 to the n plus number 2 is inferior or equal to this term. I'm going to simplify this one. This one becomes minus 2 here. 3 to the n as a common factor. We'll have 3 to the n factor number 3 minus 2 minus number 2 here. So this one becomes number 1 here. This one becomes 3 to the n minus 2 here. So I'm going to cancel out 3 to the n from both sides. I will be left with 2 to the n is plus number 2 is inferior or equal to minus 2. Okay, this one it's clearly is a contradiction also. I have no solutions at all when we have n is superior or equal to 2, because we already took the case n equals 2 was not a solution as well, which means we are going to include this case with this case as a general case solution. So the only solutions that we found when we have n equals 1, we found these solutions. Okay, so I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching, and we'll see you next video. Bye.